When you hear the word equation, equation should bring to mind an equal sign. Inequality means it does not equal. So it's really any type of solving that is not equal. And so the definition here on this first page says an inequality is a mathematical sentence stating that two quantities are not always equal. So you can have different types of inequalities. And these symbols hopefully look familiar to you. You have the less than symbol, greater than symbol, and not equal to. Those are all inequalities. And then combining these with equality, you have less than or equal to, greater than or equal to. And they give us some examples. 4 is less than 6, 5 is greater than 3, -2 and 4 are not equal, -1 is less than or equal to 8, and 6 is greater than or equal to 0. And so you have types of inequalities. You have what's called a trichotomy property. If A and B are real numbers, then one of these three things must be true. Either they're equal, A is bigger than B, or A is less than B. Those are the only options if you have two real numbers, all right? And so that's what that property says. So far we've only been dealing with equal, and now we're going to move into what happens when they are not equal. So it says state an inequality that is equivalent to X is not less than or equal to Y. Well, another way we could say that is that X is greater than Y. All right, so when you think of opposites in the inequality world, then you can think about, well, if it's not less than, then it must be greater than. And they included equal to so that you could eliminate that one as well. All right, so the first thing we're going to look at is, are they solutions? So does this answer the statement truthfully? So filling this in should give you a true statement if it is a solution. So the first thing we're just going to say is 2 a solution? Well, you fill it in. 2 plus 3 is greater than 6. Is 2 a solution? No, because that's a false statement. So 2 is not a solution there. Then you would say, well, is 3 a solution? 3 plus 3 is greater than 6. No, 6 is not greater than 6. That is not a solution. Then we say 4 plus 3 is greater than 6. Is that true? Yeah, so 4 is a solution. So when you're talking about solutions for inequalities, you actually could be talking about a set of numbers. When we had equations, you were solving really, for these equations we've done so far, one answer. So only one answer worked. If I gave you an equation and said solve it, then only one answer worked. But for inequalities, you're actually giving me a set of numbers. A set of numbers actually makes these statements true typically. And so one of the ways that we represent sets of numbers are number lines. And hopefully, again, you are all familiar with number lines. For example, 3, it says graph X is greater than or equal to 3. Well, that's a whole set of numbers. It's not like just one number answers that question correctly. There's a whole set of numbers. So on a number line, greater than or equal to goes to the right, less than goes to the left, right? And so if I want to graph this, I'm going to start at that -3. The first thing I'm going to decide is, does it include -3? Could -3 be an answer? Well, yes, because it's or equal to. And so if it includes that number, then you are going to draw a closed circle. The closed circle indicates that it also includes that number. All right? It includes it. And then you are going to shade the side of the graph that makes this true. Well, if X is larger than -3, I am going to graph everything that is bigger than -3. And you can indicate that by just shading some of it, and then you draw this arrow. The arrow indicates it keeps going. It keeps going infinitely. Now, it does not just include -2 and -1 and 0. It actually includes all the numbers in between. So we are shading it to indicate it's every number, including those decimals that fall in between it. All right, so graphing those is fairly simple. Graphing X does not equal 2. Well, we're still going to start at 2, but is 2 included? Well, no, they specifically told us that it does not include. So we are going to start at 2, but now we're going to put an open circle because it does not include 2. And then we're going to shade everything that is not equal to 2. Well, that's going to go on both sides of the graph. That's going to go to the right, and that's going to go to the left. One more example. Write an inequality that describes this. Well, I want to represent the set of numbers. We're starting at 80. So obviously, 80 is going to be in my answer. Is it smaller than 80 or bigger than 80? So X is going to represent my group of numbers, and I just need to know if that group is smaller than 80 or bigger than 80. Is it smaller or bigger?
Smaller.
Smaller. And does it include 80? Yes. So I indicate that with that extra line that looks like an equal sign. So is at most, you should have gotten that it was D, less than or equal to, is not greater than or equal to. So it is not greater than or equal to. That means it must be less than. Is not less than. Well, that could be greater than or equal to. C. Is at least. At least. That's going to also be C. If you want your grade to be at least a 90, it means you want it to be greater than or equal to 90. Is not as much as, that's going to be less than. It doesn't include it, and it's not as much as it. Is greater than or is less than. This one's going to be not equal to. Exceeds, that means it has to be larger. Does not exceed, that means it has to be smaller or equal to. All right. And determine whether it's a solution, you needed to just fill it in. -1, -7, that is not larger than -3. 4 minus 7, it is greater than or equal to. And 8 is greater than. The first thing we're going to look at here with properties of inequality is what can you do to inequalities? So the first question they ask, is 5 less than 7? Well, yes, 5 is less than 7. And so then what we do here is we are adding 2 to both sides. 5 plus 2, 7 plus 2. We've added 2 to both sides. And now we have 7 is less than 9. Is the inequality still true? Yes, the inequality is still true. Adding 2 to both sides did not change my inequality. The next one they have is a greater than. Is 2 larger than 0? Well, yes, it is. Then they subtract 9 from both sides. They're subtracting. They have -7 is greater than -9. Is that also true? Yes, subtracting did not change the inequality. And so the first property we're going to look at is the addition property of inequality. If you have 2 numbers and they are set with an inequality, you can add or subtract from both sides, and it will not change your inequality. How does this help us? Well, we can solve them just like we solved equations. Look at the example 1. Solve and graph. All right, so they want us to solve these, and then they want us to graph them. All right, so the first one is x plus 7 is less than 8. How would I solve this for an equation? Well, I would subtract 7 from both sides. So that's what I'm going to do here. I get x is less than 1. The answer to this one is going to be an open circle on 1 because it does not include it. And x is less than, so everything's smaller. All right? That would be my graph here. Okay? Look at the next one. We have that x minus 5 is not equal to 3. X minus 5 is not equal to 3. Well, in the equality world, we would just add 5 to both sides. So in the inequality, we add 5 to both sides. We get an x is not equal to 8. So if I'm graphing this guy, open circle on +8 and everything that does not equal +8. So my graph for this one would look like that. All right, It doesn't matter if it's decimals. If it's decimals, you do the same. We would add 0.4 to both sides. We get negative 0.2 is less than or equal to x. So when you're graphing something like this, you need to think about where it falls. We're not going to get a ruler out and decide this, but negative 0.2 is in between 0 and negative 1, right? So somewhere between 0 and negative 1, we're going to do a closed circle. Is x smaller or bigger than that? Is x larger or smaller? Yeah, x is larger than it, so we're going to go this way. So when it's flipped like that and your number's on the left-hand side, pay attention. Just ask the question, is my variable bigger or smaller? I am always graphing my variable. Three is less than 5. This is a true statement. So now they are multiplying both sides by the same number. And you will see when they multiply both sides by the same number, the inequality is still true. Even if it is a less than. But what are we doing here? We have 4 is less than 6. That is true. But now we have negative 2 that we are multiplying by. So when we multiply by negative 2, we have negative 8 is less than negative 12. Is that true? No. That is not true, all right? And so this is no longer true because the inequality actually reverses when you multiply by a negative, all right? And so the multiplication property is a little bit different. If you are multiplying by a positive number, everything stays the same. But when you multiply by a negative number, it actually flips that greater than or less than sign. All right, it actually flips it. And so you see happen, if I have a little example here, we'll just move this over.
Channel 2.
When you have a list of numbers, you can kind of see it. 3 is less than 5. And so you'll see it actually flip when you cross it. So if I multiply both sides by, let's say, 2, all right, so I'm going to multiply both sides by 2. That's not going to change it. I'm going to get 6 is less than 10. Multiply by 1. You get 3 is less than 5. But when I multiply by 0, something happens. If it's just a less than, we have a problem because 0 is not less than 0, right? But even if this was or equal to, 0 isn't a problem had it been or equal to. But something changes right here because all of a sudden, when I multiply by negative 1, I get this problem. We have a problem, all right? Negative 3 is not less than negative 5. And so it's when you cross it is when the problem happens, all right? Because really what you're doing is you're telling me the opposite of both sides, which is going to flip. Opposite jumps it to the other side of the number line. And so both of them have jumped to the other side of the number line by making it opposite. And so you have to also flip your greater than or equal to. These inequalities I'm going to treat just like equalities, except I need to pay attention to what I am dividing by, okay? When I say that, it's whatever is with the variable. So for this first one, I have negative 3x is less than negative 9. What am I going to divide by? I am going to divide by the negative 3, all right? Which means I have x on this side. Negative 9 divided by negative 3 is positive 3. But because what I divided by was a negative, I am going to flip that. And it's going to look like that. The next one, what's happening here? X over 12. What process is happening? What operation? That's division. So how do I get rid of it? Multiply. What am I multiplying by? 12. So I multiply this side by 12, and I multiply this side by 12. Did I multiply by a positive or a negative? 12 was positive. The number that was with my x was positive. I actually don't care what the other number is. The other number was negative here, but what I was actually multiplying by was positive. So this one's going to stay the same. And so x here is going to be greater than negative 48, all right? It does not change there. Let's look at the last one. I am multiplying by a fraction. How do I get rid of it if I'm multiplying by a fraction? Divide. And so what's the process to divide by a fraction? Keep, change, flip, all right? So I am actually going to multiply by the flip of this, right? Multiply by negative 2 over 5. Multiply by negative 2 over 5, all right? I multiplied by a positive or a negative? Negative. So this will become x. This guy needs to flip. He's going to be less than or equal to. And remember, you can cross cancel here, or you can just multiply negative 50 divided by 5. You should get a negative 10 here. And so anytime what is with the x that you are multiplying or dividing by is negative, that's when you flip it. So I don't care what this one is. I only care what is with my x.